R. This is my probably RL. Okay, so this has to be converted into a Thevenin's equivalent circuit. Thevenin's equivalent circuit, that is VTH connected in series with RTH. VTH connected in series with RTH, and this terminal A and this terminal B, A, B will be there. So what will be connected here, students? What will be connected across A and B? RL. What is RL here? What is RL here? Please respond, students.
Resistance.
RL. What is the value of RL?
2 ohms, sir.
2 ohms, sir.
Okay. Now please compare the given circuit and the equivalent circuit. In the given circuit, how many voltages are there? One voltage is there. Okay. Now, in how many resistance are there? How many resistance are there?
4, sir.
Okay. Like we exclude RL. Excluding RL, how many resistance are there?
3, sir.
3. So, but in equivalent circuit, this is our equivalent circuit. Okay. This is our equivalent circuit. This is the equivalent circuit. So, in the equivalent circuit, we have got one voltage and one resistance. Okay. Please listen carefully. This voltage and this voltages are not same. VTH is not equal to 30 volt. Okay. It is not same. Now, this RTH is going to be something different. Combination of this resistance only, we are going to find out RTH. We are going to find out VTH and RTH. VTH and RTH. Okay. Now, the first step 1, calculation of, note down, step 1, calculation of Thevenin's voltage, VTH. Need not write full Thevenin's voltage. You just write calculation of VTH. Noted?
Yes.
Yes. Have you noted?
Yes, sir.
Okay. To find out the Thevenin's voltage, what should you do? To find out the Thevenin's voltage, what should you do? Remove, open circuit the load resistance. Open circuit the load. That is the resistance connected between the terminal A and B. Okay. So please draw the circuit by open circuiting the terminal or the load resistance. I have open circuited the terminal A and B. The resistance which are there is removed. 2 ohm is removed. Now this is 30 volt. And this is 12 ohm. This is 6 ohm. This is 4 ohm. Okay. Now these two terminals are open circuit terminals. These two terminals are open circuit terminals. Okay. Now, Ren and Soumya, don't enter anything in the chat box. Please note down the absentees. You need not put anything in the chat box. Okay. Now, so this terminal is open circuit terminal. Voltage across these two terminal VAB is equal to our VOC, open circuit voltage, or equal to Thevenin's voltage. You understood? Voltage across the terminal A and B, or the voltage across the terminal open circuit terminals, is equal to Thevenin's voltage. Is equal to Thevenin's voltage. Okay. Now, how to find out Thevenin's voltage? Between the open circuit terminal, what are the resistance available? Please listen carefully. Please listen carefully, students. VTH is equal to voltage across 4 ohm. Voltage across 4 ohm plus voltage across 6 ohm. Voltage across 6 ohm. Voltage across 6 ohm. Okay. Now let me apply how many loops are there in this circuit, students? How many loops are there? Closed loop.
1, sir.
Only one closed loop. Only one closed loop. I. So this is plus, this is minus, plus, minus. So is there any current flowing through 4 ohm? Is there any current flowing through 4 ohm? Is there any current flowing through 4 ohm?
No, sir.
No, sir.
No, sir.
Current flowing through 4 ohm. Voltage across 4 ohm is what? 0. Right? So voltage is equal to
Yes,
what?
sir.
I into R. Right? So when current is 0, obviously voltage across 4 ohm is 0. You understand,
0.
students?
Yes, sir.
Yes or no?
Yes, sir.
Yes, sir.
Okay. Oh, one more thing. I'll ask one more thing. Why I have taken VTH is equal to voltage across 4 ohm plus voltage across 6 ohm? Can somebody say? Why I have taken VTH is equal to voltage across 4 ohm and voltage across 6 ohm? Even your answer is wrong, no problem. I'll correct it. Response, students.
Resistance connected between terminals A and B, sir.
Very good, very good. So between the terminal A and B, there are two resistors connected, with 4 ohm and 6 ohm. That is the reason voltage across 4 ohm and voltage across 6 ohm is taken. Voltage across 4 ohm is 0 because current flowing through 4 ohm is what? What is the current flowing through 4 ohm? This current is 0.
0, sir.
Current is 0 amps.
0.
So that is the reason. Because why the current flowing through 4 ohm is 0? Why current flowing through 4 ohm is 0?
Because it's an open circuit.
Because it is open circuit. Okay. Now we have to find out voltage across 6 ohm alone. To find out voltage across 6 ohm, I'm using KVL for this loop. Okay. So current flowing through the mesh is I, 12 minus 12I, minus 12I, minus 6I, right? Plus 30 equal to 0. So I is equal to probably 18, I is equal to 30. Okay, so I is equal to how much? 30 divided by 18, that is 5 by 3 amps. 5 by 3 amps. Okay, now, so current is calculated. How to find out voltage across 6 ohm? 6 ohm is? So we have calculated the current, right, using the formula. Voltage across 6 ohm is equal to 5 by 3. Ohm's law. I into R. 5 by 3 into 6, that is 10 volt. Right? So VTH is equal to 10 volt. You understood, students? Being the first problem, try to understand the concept very clearly. If you have any doubts on this concept, please ask. So you need not draw the diagram once again. We have drawn the diagram earlier. Since it is there in the presentation, you do need not copy down. It's not required. Already we have drawn it. Okay. Whichever you have not noted, even in the steps, these two steps already we have completed in the previous slide itself. Now this step and this step you have to note down. Any doubts on this VTH calculation, students?
Sir, can you repeat again?
Which one?
Sir, how to calculate 6 ohm. Voltage of 6 ohm. Yes, sir.
Any doubt on this current which you have calculated?
No, sir.
Okay. Now we have got only one loop available. Okay. So current flowing through this loop is I. So this is plus minus. So this current is I, this current is I, and this current is also I, and plus or minus. Okay. Now voltage across 6 ohm is basically V voltage across 6 ohm is voltage, Ohm's law, I into R. So what is the current flowing through 6 ohm here? Current flowing through 6 ohm, and the current flowing through the entire loop is I. So it is I into R is 6. So I is 5 by 3, R is 6. So this is equal to 10 volt. Now you understood?
Yes, sir.
Others, what about others?
Yes, sir.
Yes, sir.
Sir.
Yes.
Sir, in the above slide, VTH is equals to 4 V4 ohm plus V6 ohm. Why don't we take 12 ohm, sir?
So that is the reason, like when I asked the question in between, Aloysius said something. You remember? Now between the terminal A and B, so VTH or VOC is between the terminal A and B, what are the resistors available? So that voltage drop is going to be open circuit voltage. Open circuit voltage. So right, between the terminal
Yes.
A and B, 4 ohm is connected and 6 ohm is connected. So that is the reason voltage across 4 ohm and voltage across 6 ohm is taken for voltage across the terminal AB. So VTH or VAB or VOC, open circuit voltage. So that is the reason we have not taken the 12 volt here inside. 12 volt is not part of the open circuit terminals. 12 volt is not part of open circuit terminal. 12 volt is part of some other mesh or some other loop. That is the reason 12 volt is not taken for open circuit voltage. Now you understood?
Yes. Yes, sir.
Name is Shiva.
Chevy.
Shaivi, right? What is the
Yes,
name?
sir. Shaivi Tamarkar, sir.
Shaivi Tamakar. Okay. Now you understood Shaivi?
Yes, sir.
Very good. Any other doubts?
No, sir.
Okay. Shall I move on?
Yes, sir.
Okay. Now the calculating the Thevenin's resistance. Calculation of Thevenin's resistance. Okay. Step 2. Step 2. Okay. Please note down. Step 2 is calculation of Thevenin's resistance RTH. Calculation of Thevenin's resistance RTH. Okay. Now, what should you do? For calculating the Thevenin's resistance, though the circuit diagram is available, right, we should remove the voltage, all the sources. We should remove the sources. What should you do is, once again, I'll write for you. I am having the open circuit terminals AB here, AB, right? Then we should remove the sources. Here I had a source. What source was there? Voltage source was there. How will you replace the voltage source in the superposition theorem? We know that normally voltage source is there. We will be replacing with what? Voltage source we will be replacing with what?
Short circuit.
Voltage source we will be replacing with what? Short circuit. Okay, so this is 12 ohm and this is 6 ohm. This is 4 ohm. So the equivalent resistance across these two terminals is RTH. Equivalent resistance across these two terminals is RTH. You understood, students? What is the procedure to calculate RTH? Remove the sources. If there is a voltage source, remove the sources with short circuit. And if there is a current source, probably next problem we are going to have it with current source. If there is a current source, remove this current source with open circuit and redraw the diagram with open circuit terminals. And the resistance across the open circuit terminals are going to be RTH or TH. Okay. Now I explained about how to calculate the equivalent resistance for series parallel combination. This circuit can be redrawn as like this. So this is parallel. This 12 ohm and this 6 ohm are connected in parallel, right? So having it here or having it here, both are same. Okay. This is 12 ohm. This is 6 ohm. This is in series. 4 ohm is in series. Okay. So this is the terminal A, B, and this is RTH. Okay. So 12 ohm and 6 ohm are in, 12 and 6 are in parallel. Okay. So 12 into 6 divided by 12 plus 6. Can I have the answer?
8 ohm, sir.
8 ohm. 12 into 6 divided by 12 plus 6. Please have calculator, students.
Four, sir.
12 into 6 divided by, yes, how much?
4 ohm.
4 ohm. Right? So you can redraw the diagram once again. Yes. Redraw the diagram. This is going to be, so you'll have 4 ohm and another 4 ohm. So this is my RTH. So this is my RTH. So this is 4 and this is 4. So 4 and 4 are in series. So RTH is equal to what? 8 ohm. Okay, so this is how we found the RTH value, 8 ohm. RTH or RAB. The terminal resistance between the terminal A and B. The second step is over. You understood, students? Yes,
Yes,
or
sir.
no? See,
Yes,
what
sir.
I explained
Yes,
in
sir.
the initial stage, the basics, everything will follow. You have to know, right? The basics is not given just for time pass. Okay, shall we move on? Okay.
Yes,
Yes,
sir.
sir.
Third
Yes,
step,
sir.
students, what is the third step? What is the third step?
To find equivalent circuit.
To draw. It is not finding actually. You have to draw. We are going to draw the Thevenin's equivalent circuit. We know Thevenin's equivalent circuit, VTH connected in series with RTH. So finally, we'll have the resistance R. Okay, Thevenin's equivalent circuit. So VTH we found that 10 volt and RTH we found that 8